100,000 scientists across all fields worldwide. His Google Scholar citation is over 238,000 with an H index of 240. Now let's welcome Professor Zhonglin Wang to give us the lecture about the triple electric nanogenerators for self-power systems and large-scale blue energy.
Thank you for the introduction. Let me get this minimized size. And I'd like to thank the invitation from Micro Nano Letters, and this journal is grow very great and reach impact factor almost 10. So it's make a great contribution to the society and community. So I'd like to use this next 30 minutes to give you a brief talk on our triple electric nanogenerator for self-power system and large-scale blue energy. And when you talk about energy, there's a lot of need. I also serve as the chief editor of Nano Energy, this journal. And as we march, the society march from the ancient time to today, the energy need changed too. We still rely on the traditional energy based on coal and oil. Each change in the energy revolutionized our society. So as we enter the 21st century, there's a lot of new challenges and new opportunities. So what are the new opportunity, new challenge related to energy? Our traditional way to deliver power is through the central power plant, through the cables to factory, to schools, to home, to the city. And we also have the storage units, which storage the energy for portable electronics, for mobile electronics. So these are the major two approaches for power delivery. But once we enter to the, furthermore, the people's demands, the society's needs are increased dramatically, especially in the area of handheld electronics-based devices. This large increase, so-called big data. You know, we have a data. Where the data come from is from those devices. With smaller size, huge numbers, mobile and wireless. So how do we meet the energy of those devices is what we are looking at. So if you look at this energy delivery here, is basically we look at it from the traditional power plant to your home. So this is a cable power delivery from concentrated energy to fixed sites, ordered delivery. But as we into the Internet of Things, mobile phone-based electronics, there's a lot of distributed energy. So from concentrated energy to distributed energy, from ordered application to some sort of disorder, from wired to wireless. So this huge numbers increase every day. So therefore, you can view this one as analogy to the entropy in chemical physics. And the entropy for energy distribution is very different from what we used to do. So how do we meet this daily increased demands, society and whole global? So we introduced this solar-powered system 2006, 15 years ago, I introduced solar-powered system. Can we make this device not only sense the environment signal, but also process and send a signal wirelessly to wherever it should reach? And this device can be self-charging without an external power source. That's called solar power system. And that's today become very much popularly utilized in many fields. Okay, so today I just present one of our major inventions made in 2011, and it's called triple electric nanogenerator, called TENG. This is one of the mode of TENG called contact separation mode. Two dielectric materials contact separation and the surface being charged. Then if the distance between the two dielectric be increased, the electron flow from one electrode to the other. So this is the way we have been talking about the energy generation, right? Energy generation here. So we knew this one, but what is the fundamental? What's the application and what are the challenges? So let's look at it. If you want to see the advantage of the traditional power generator with the new generator, what's the advantage? What's the key difference? Okay, it's not only just the choice of materials, it's way much beyond that, go to physics level. So this is the metal rod called electromagnetic flux, and this is the contact electrification between two dielectrics that give you the power generation. Let's see the difference. Let me just show you the difference. Okay, you see? This runs at a very fast pace. This runs at a very slow pace. Okay. Let me introduce to you. So this why this have to run at a fast pace, because the power output is low. If you run a slow pace, it cannot drive it. But this one is slow pace, but the power is enough for those lights. The key difference is this. See, this is the frequency dependence. At low frequency, the TNG output is a lot higher than the electromagnetic generator. So what is this low frequency? Is the frequency in our daily life. So TNG is a very powerful technology for harvesting irregular, low frequency, distributed energy at a high efficiency. Okay, so now come to the basic. When you talk about these things, what's the basic science? If you talk about trouble electricity, everybody knows it, but not everyone even understand the fundamentals of trouble electricity. For example, in the textbook you write metal is a plastic rod rub on the fur, you get the electrostatic charge. The question is why? Why this negative charge? Why these other positive charge? So this is the fundamental ones. So we have studied this for the last few years, and we propose some models. Let me just review one model for this. Because the trouble electricity occurs for any materials, any phase, solid, liquid, gas phases. So it needs a generic model. So we propose this two atomic wave function overlap model or electron cloud overlap model. So this is one atom, this is the other atom. If the separation between two is slightly larger, so there's no overlap with the electron cloud. Now, if you bring the two together, the barrier, you see, the barrier used to separate the transfer electron from here to here is lowered. So electron can transfer from one side to the other one. If you do an animation, it's look at that like this. This is the bonding atom, electrons here, this bonding atom here. Then you bring together, and then new potential become lower the barrier, the electron transfer can occur. So this electron transfer occurs, this is the trouble electricity. You can use this model to explain for solids, liquid, gas, or liquid and gas. Okay, so in this such a case, electron remains on one atom, and the other one will have positive charge, the other one negative charge. And this is the case we have observed from many materials. So this kind of transition we have studied a lot in this regard. So just briefly tell you, because of time limitation. So used to believe, so what is the tribal electricity? Is a type of contact electrification in which certain material become electrically charged when they are physically contact. This definition is partially right, is partially wrong. The partial right is that it just give you two material contact give you, but did not explain why. So the definition is contact electrification is a quantum mechanical electron transfer process that occurs for any materials in any states, liquid, solid, or gas, in any application environment, and a wide range of application range temperature. We found up to 400 degrees C it still exists. So we complicate the situation of trouble electricity and contact electrification. This is a scientific term. This is an engineering term. We just use tribology convoluted with the scientific term become engineering operation. So therefore, we used to do not understand this very well is because we complicate the process. Okay, so this is what is happening. The second one, if you have this electrostatic charge, how come it make electron to flow? Used to be you have a metal rod called magnetic flux. The Lorentz force drive electron to flow, you see conduction current. But in our case, it's different. This goes to Maxwell's equation. Much different from this. Maxwell's equation was proposed for electromagnetic wave, but we expanded Maxwell equation for energy. So how? If you look at this displacement current term, this Maxwell introduced in 1861. This is the standard term. This is the time variation of magnetic field, electric field give you the current. It's not a direct flow of current. So this one, if you see, in our case, this medium polarization term missed one term. What term? If you have a surface charge due to trouble electricity, you have a natural contribution to this polarization here, even there's no presence with electric field. So we added one term in the Maxwell equation. Say here.
Dear audience, we are experiencing some technical problems at this moment. So I guess there's something wrong with the internet connection from Professor Zhonglin Wang's side. So we are dealing with this. Please keep your patience. Thank you.
Help. Derivative here. So why do we still call nano generator, which was first introduced, used nanowires for power generation, but now is displacement current driven power generator technology. And for piezoelectric case, for tribology case, it's all inclusive. So we call nano generator, which stands out of the traditional power generator technology. So nano generator is a field that uses displacement current as the driving force for effective converter mechanical energy into electric power. Even use nanomaterial or you don't use nanomaterial, it doesn't matter. So therefore, it's a physics change as we are speaking. So what fundamental contribution? The fundamental contribution is this: is modified displacement current. Originally, Maxwell used this to predict the electromagnetic wave, and it contributed hugely to today's society. But now, if you add an additional term, is the power generation of nano generator here, which is the energy and the sensors. And we use this one, expand Maxwell equation here. So basically, this term is low frequency. This term is high frequency. Two are normally do not couple, but now if you couple them together, you can have a lot of new things to happen in the future. But today we just totally talk about this term. So this gives you the basic theory of this theoretical framework. So I just, to be brief, okay? So now, when you talk about the TNG, what are the applications here? Let me give you some introduction here. The first one is use human activity for power generation. Okay, if you put in a shoe insole here, use a little tubular structure here, you can get a lot of power out of this. At least it's enough for some small electronics here. So you can use conventional materials as a power converter, use human motion here. You can also make solar-powered electronic papers. The paper can be electronic power. You can see this one. Let me show you. You can use this one to drive change the color of the paper as your physical motion here. So you can imagine you can future have a T-shirt, and the T-shirt can change color when you are jogging. See, the color changed here. Let's swap one more time, and then you can get another one. Okay, become red. The other one, I can make this color switches. You see, just once the color switch from one side to the other side here, you can make an automatic color change, and also with the green and the other colors too. See, okay. Just physical motion made it change. Okay, let me just show you the slide here. Okay, and then you can also have other devices as well. Self-drive electronic paper-based device here. Okay, let me see this one. Yeah, so you can make all kind of good things from this things here. You can use the material choice can be very diverse. Use a silicon. You can have multiple twist ones here. It's become a little power generator and a sensor. You put it on a person's arm. You tap in any specific point. You have a signal being received here. This is for sensors. You can also put on the floor. Some people's free walking. You can have a power generation here. Okay, so this is all needed, not only for power generation, but for picking sensors. Medical purposes. You can use heartbeating of small rat to drive a pacemaker. And recently we made this one to be used. This one to drive a large, the basic human pacemaker. And we make use large animals. This is a big pig, 50-kilogram pig for the experiment. We found that the breathing of this pig, the motion that drive this TNG can drive the pacemaker. So this for the first time it changes a lot. And this one can also send signals. You not only can detect the power of the pacemaker, but also can detect the signals in vivo. And inside the body, we have reached almost half microjoule our power output, but the minimum energy drive of pacemaker is 0.37. So we already go through beyond the threshold. So this is a very exciting news, and our effort for 12 years, finally we reached the possibility for self-powered pacemaker. And this drug delivery with use TNG, without use TNG, put on skin, you can infiltrate the drug into deep tissues here. You see, the efficiency enhanced by a factor of 5 if you use our TNG. Just physical motion change the effect delivery of drugs by a factor of 5. Fabric, a lot of people do fabric studies here. How can you make a fabric smart? Trouble electricity is the very basic effect. You can make this one into different design here, and you can also make this one into a power generator. You can also make this one into sensors here. So our group was the first to demonstrate fabric-based, fiber-based nano generator and the sensors here. So you see, trouble electricity is very popular in the fabric structure here. So this is the fiber-based ones. Raindrop. 2014, we demonstrated for the first one use raindrop for power generation. In recent years, many groups started raindrop, but we were the first one to demonstrate this one because raindrop have the charge on the surface and also charge exchange with the surface here. When drop hit the substrate, you can have a charge exchange, and then when the drop float off, you have a power generator. You can see this. This is the power generator here, and this is the lights here. Use this flashlight here. You put on from here, you see the light flash. Okay, so then turn this off. So you can see this one is raindrop as a power generator here. A lot of interest study recently here. You can use it as a model. Okay, this is the electrostatic model. You can use the TNG to drive electrostatic model because TNG have a high output voltage, and this is very unique for electrostatic application. You can see this is sliding on the right hand side, and this model runs at 1300 round per minute for medical purposes for some of the solar-powered model sensors here. Okay, many people work on storage, energy storage, but for our system it's different because the energy from the environment is variable. It's faster or slower, frequency variable, amplitude variable. Through our TNG, we can make into power, but it's pulse power. So we have through a power management, then through a storage unit for regulated application here. So we call self-charging power unit. It's a unit that can harvest energy, manage energy, and storage energy, and then you can utilize the energy. So it's different from battery. Battery is just a storage, a simple storage without the previous two components. The three components are all equally important for this device application here. So this is the reason we make the power management, because the TNG has a high output voltage, lower output current. Our purpose is to lower the voltage and raise the current. So you can see this one. You can see this. This is the power. This is the TNG, and this is the power regulation unit, and this is the output. You can be a effective user. We already reached 85% of this effective power management here. Okay, so this is the utilized for power management system for self-charging power unit. In the environment, you have a lot of sensors. You have wind sensors, you have chemical sensors, you have gas sensors, fire protection sensors, widely distributed. Can you use the wind to power this? Yes, we can use this tongue shape. This is a polymer. When wind go through this one, this tongue oscillates. You see, early day we show this one. You see, when you blow this, the wind go through here. So we make this a few units stacked together, and then when wind go through here, the power generated here can be integrated and send a signal wireless. We already achieve at a wind speed of about 4.5 meters and 2.5 kilometers away. We send a signal once every 18 minutes at a radio frequency. So we can do wireless communication here. You can imagine if you have water quality tracking, environmental monitoring, many monitoring, you make a map across the field, use solar power technology here. You can prevent nature disaster. You can put in the ocean, use the floating water to power a light pole. You can also use this one for chemical sensors here. You can do this one, use the floating waters to detect chemistry of the water and send a signal wireless to the side here. You can also use this one for a variety of like earthquake predictions, landsliding predictions. This is the landsliding prediction here. In some areas, landsliding occurs at midnight. Nobody knows about it, but you can do this as a warning system. Use our TNG as a trigger, as a sensor. So power sensor is another application for TNG. For example, when you play ping pong ball, if the ping pong ball strike the table, you can strike on the top edge is a valid ball, but if you strike on the side of the ping pong table, is an invalid ball. Let me show this one. You can see our people demonstrate. You see the ping pong ball strike here is a valid ball. We detect the signal, and then if the ping pong ball just touch the side rim, you get another signal which is not an invalid ball here. So basically for sports, TNG has a huge application. And this is just used because you can use any material you want, any structure you want for sports, for volleyball, basketball, for tennis, whatever. You can use it as a sensor and a trigger. Okay, this is for typing. You make a keyboard to record your typing. When you type a text, the way not only record the alphabet you type, but also record the way you type, the time interval between the two and the difference between the two. And you see this one, we can identify who typed it. Who typed it? So not only just the input information is correct, but who typed it? This is our people demonstrate. I have 6 figures. This is 6 figures. So you can use a finger put in. The computer recognize who typed it in. The reason they recognize is use the smart keyboard developed based on TNG. If you go to library, you have 1,000 books. If somebody touch a book, you don't know. Okay. Even use a video, it's very hard to surveil such a large number. But we can, for each book, we can build a TNG here. And when anybody touches this one, there's a signal sent to the receiver. We can know which book was touched. Let me show you this one. So you see, this book is being removed. Another book is moved. So this is for solar-powered sensors here. This is can really useful for documentation tracking, because the reason, if even you have this over there, somebody touch it, you never know. Even use a battery to charge it, the battery way gone without power, because maintains the power is very difficult and resource consuming. And we can make this one for robotic, soft robotics. Remember, soft robotics need power, need this sensors here. You need to make, so our TNG can make a soft robotics have a very unique sensor. Okay, for the blood pressure measurement, if you put on this one, the risk here, you not only measure the pulse, but you also measure blood pressure. And you see, many people used to wear this iWatch and thing. I don't see very many get any popular, because I had one. I only wear it for 2 weeks. I just get rid of it. It's always need to charge. You always have some other things that didn't measure it accurately, so I didn't wear it at all. So this one, you can see that these things can be measured your pulse. This is for medical care. Is the care. It's not only just the pulse, number of pulse, but also the pressure, blood pressure. And robotics. You use a paper-based hearing aid put in robotics. You can have a microphone as a music recorder, and then you play back. See what it is. Look, let me show you if you can hear me. Can you hear the music? I hope you can hear music. Okay, this is the traditional music here. Use this as a microphone, paper-based TNG as a microphone to record it. Then you play back. This is the playback without any digital filtering, any other the data processing, just a native play. You can see 90% of accuracy of sounds has been preserved. This is not only for that, can be for robotics communication. A human with robotic communication. Remember, use a paper-based TNG has a microphone, which you never have been able to do before. Okay. Voice recognition. They didn't recognize because this is the how you come over. You can see voice recognition utilize our TNG-based microphone, which is very interesting here. Okay, blue energy. What is blue energy? Energy in the ocean is huge. Just the coast area around the globe is 75 terawatt. This is 4 times of the energy power the whole world. But having such energy is extraordinarily difficult, expensive, difficult environment, high cost, and corrosions are very difficult to operate and low efficiency because you rely on classical technology. How about our new technology? So how do we do it? So we have not utilized energy offered by the ocean. So how do we do it? So we make a sphere and a sphere. Inside the sphere, we have another sphere. So if in the water wave, if this wobbling back and forth, you can see wobbling back and forth, power generate. The reason because this ball rolling back and forth, contact separation, get a power generation here. So this is a way to produce power. Just one ball. Okay. If you have, how do you see the way, because the trickling frequency is slow, but how can you enhance the trickling efficiency? We use this pendulum structure. So if striking this once, they can oscillate 80 seconds without stop. Without this one, we can already achieve 28% of energy conversion efficiency, which is far beyond whatever any existing technology for mechanical energy conversion. You can see this in the water, and this is the light wind. You can have the heavy wind, but for light wind, you cannot do it. But our technology can do it. So basically offer a brand new approach, a groundbreaking technology for harvesting wind energy and water wave energy, complete different thinking. If you put this one, regardless of the depth of the ocean, regardless of the low frequency, we can do it. We can do it. So how do we do it? We put on the surface, you can see in the water, each is floating, and we can put it on the surface of water, make it networking. 3D networking, you can harvest energy. This can offer a brand new approach for harvest energy from wind, from water wave, from anything, regardless of depth, regardless of distance, it make it possible. So this one can be integrated. So this is called blue energy. So fundamental, what's the difference? Always I emphasize fundamental things. You have to be physically different. This is the electromagnetic generator. The power output is the square of the frequency. Use magnets, coils. This is the traditional technology. You cannot change it. Over 180 years. What we do is here is linear with frequency. So therefore, we use polymer materials, organic materials for mechanical energy harvesting. Fundamental difference is that low frequency electromagnetic generator has no output, very little. But ours is many times higher. So basically, this is the killer application. We can do the things traditional technology cannot do. So therefore, at low frequency, we have the unbeatable advantage in comparison to the classical technology. So we are not talking about replacement, but we can do things classical technology cannot do. Okay, so this is the physical difference here. Then we make this one. You can see this is the power generator here. You can see in the water. Okay, you can put it in the water, and then you can simulate in the water flow here. So all this experiment being carried out. So very interesting, very different from classical way to do things. Okay, so the way I present to you is of a new approach for this one. So we hope for this of a new way for future of world energy. When we run on fossil energy, what are we going to do? Okay, I think as long as there's wind around in the ocean, there's vast energy we can harvest. So if we can expand this technology, we have provided an unprecedented approach for solve the world energy at large. Okay, so I think my talk is short because only 35 minutes. I cannot talk very much in detail, but I hope to give you a brief review. First one, what's the fundamental of content electrification? We have many papers in this regard, which is the question remain for 2,600 years old. Very old physics phenomena, but not clearly understood until now. So therefore, it has quantum mechanical electron transition there. So this is the first thing I present. The second one, what's the difference of our TNG compared to classical technology? Is Maxwell's displacement current, is not the traditional conduction current. That's the difference. So people always ask me, say, tell me why you still call nano generator. So when we propose nano generator, we use nano wires. We use nano wires as the source for power. If you can say you have a nano wires, use the EFM tip to trick it, you get power. We call nano generator. This was 2005, 2006. But that time we did not understand the fundamentals of physics of the power generation for our technology. Until recently, we understood it is Maxwell's displacement current. Therefore, so nano generator is a field that utilizes Maxwell displacement current as the driving force for converting random, low quality, distributed mechanical energy to electrical power. So that's the definition of nano generator. You can use nano materials for better performance, but you don't have to. Okay, so therefore, just like a battery, you never call nano battery because battery was created at large. But now use nano materials. Why don't you call nano battery? It's basically the principle of the battery remains the same. You just use nano material for better performance. I showed 4 major applications: micro nano power source, solar power sensor. Remember, this one have a lot of commercial opportunity, and also large scale blue energy. We have an idea for solar world energy at large, and of course, this have a long way to go. As now around the globe, have 54 countries and regions, 700 units, 4,300 scientists working in this field. This is based on the SCA data search. So there's a big field being formed. As we do nano for many years, nano is beautiful, but most importantly, nano has to be useful. We cannot just carry on beautiful. Yes, it's beautiful, but it has to solve the world problem to some extent. And we need must think in that regard, because nano has been around for 30 years or so. I remember it's around 1990s. When I was graduate in 1987, it was not called nano. That can call small particle. Until like a carbon nanotube is small, they call nano becomes more fashion. It's about 30 years or so. So now we need to think, what's the major problem you can solve? What are the unique things you can do? If you continue to call this nano for another 20 years, nobody will be care about that time we call nano or not. Let's show it works for us. It can solve real problem. I think for the whole community, micro nano community, we have to keep this in mind all the time. So nano generator have 4 major applications: micro nano power source, solar power sensors, a sensor which may not need the energy to work, blue energy at large, lastly high voltage for that. So I think there's a lot of possibility ahead of us, and I hope many young people can join this field from material science, chemistry, physics, electrical engineering, mechanical engineering, even biological engineering. It's a diverse field, need everybody's input and contribution. Thank you very much for the invitation, and I hope I give you a brief overview what we have been doing for the last few years. Thank you.
Thank you, Professor Wang. And I really enjoyed a marvelous talk today. And actually, we've got some questions raised from different platforms, and we are collecting these questions. And we are also expecting more questions. Now we have some questions here, so I'd like to show. Just pick up a few to pass it to Professor Wang. So the first question is there any limitation for the future application of TNG and blue energy?
Every technology has its advantage and disadvantage. Our major challenge faced now is the durability and robustness of the TNG, because this uses the organic materials. Sometimes you can use inorganic materials, but the system may not as stable as the classic electromagnetic generator we use now. So we are working right now how to improve the durability and stability problem. So that's the number one challenge we remain. For micro small energy, we always face the needs of every increased power density and power. So therefore, people always need more power, more power. So we are trying very hard to enhance the efficiency for the harvesting. I will also integrate TNG with other energy harvest technology, like for example, like a solar cell into a hybrid cell. For the large scale blue energy, we just at the very beginning, because this one need a very large project to do it. We currently don't have that project to do it. We just test in a lab, but we need to experiment in a real environment, because then you can work on a corrosion problem, the communications, integration of powers between one unit with the other ones, and then how the power be effectively utilized. So this is a big field to be developed in the next 5 to 10 years or so.
Okay, perfect. So the next question is about the environment. Okay, everybody talks about energy and environment. So the second question is about environment. Someone asked, will the application of this blue energy affect the climate, as it involves some interaction with the ocean, like the tidal movement? So there any effect is there?
Oh yeah, okay. So let me tell two parts, because the classical technology use coal and oil, which could bring a lot of climate change, because majorly the ozone layer damage, as well as carbon monoxide emission in our carbon dioxide emission around the globe. So global warming is happening, and because we burn a lot of oil and coal, where's the heat go? In our environment, it cannot be dissipated in space that much. So global warming is happening. So now, if you use the ocean energy, which you don't need to burn this coal and oil every day, you can save a lot for global warming. Number one. Number two, you concerned about the marine life. You see, when you build an ocean, you don't need to build a network, cover a large area, leave no space for animal to live. You can build a patch. Between the patch, have a separation, give animal enough room to live. Then how large the area you need to solve the water energy. I did a theoretical estimation. For an area of 400 kilometer by 400 kilometer, roughly speaking, is the size of the state of Georgia or the size of Shandong province. 10 meters of depth of water, you make into 3D. The total output power is the world total power consumption. Then you say, how large is 400 by 400 kilometer area on the ocean? Is 3 parts of 10,000. 3 parts of 10,000 of the surface area of the Earth. Very little bit. You can build this one in an area that no ship, no marine, not very much human activity, very complicated geographic configurations. That's good enough. So therefore, it have some environmental impact, but not as big as the fossil energy cost to us as we are now.
Okay. Third question is, yes, everyone knows that everybody pay attention to the utilization of sustainable energies, and we have pretty mature system to incorporate the energy, electricity from the wind, from the solar to get into the grid. So what do you think is the challenge for TNG to get energy into the grid?
The major challenge for solar and wind is instability. I personally believe it's a good supplement to local utilization. But if you use solar and wind energy to grid, it's caused a lot of instability in the grid and a risk. So that's why there's a limitation for both. That's